Welcome to a video presentation of Chapter 5, Section 1 and Chapter 5, Section 2. This topic, or these sections, cover fractions with common denominators and fractions with different denominators. Both of these sections involve adding and subtracting, which is why I put them together. Okay, that's not a concern. Right? The only difference is in one section you have common denominators, which should go really quick for you. And in the other section you have different denominators, which is of course just changing them so they have a common denominator, and then doing the exact same thing. So it's only logical that these two sections would go together. Now you can see at the left side of the board I've described the procedures for adding and subtracting both. To add or subtract fractions with a common denominator, remember the denominator is the bottom number, we simply add, or it could be subtract, the numerator, and of course we leave the denominators alone. To add or subtract fractions with a common denominator, we add or subtract the numerators, and we just leave the denominator alone. That really should not be the most difficult part of the thing. The more difficult part would be different denominators, and I use that word very loosely. To add or subtract fractions with a different denominator, we have to get a common denominator using the least common multiple. We change the numerators as appropriate, then use the rules above. To add or subtract fractions with a different denominator, we get a common denominator using the least common multiple, change the numerators as appropriate, and then use the rules above. Now, as you can see from the examples right, we're not just looking at fractions, there is mixed numbers involved in there, which is of course a type of fraction. Right? The only rule is when you're getting to your final answer, other than the fact that you have to show work, your answer has to be a fraction at the end, okay? I don't want them changed to decimals because all that would say to me is you've got a calculator out, change them, and add it or subtract it, okay? If it's a fraction to start with, I want fractions as answers. That only makes sense. And of course, you can't have improper fractions as answers, right? So your answer can't be 18 over 13, right? Or 1 and 7/14. You can't have that. You've either got to change it into a mixed number or change it into something else. Okay, so let's start with the common denominator problem. Again, with the common denominator, the bottom numbers, again the denominator, they're the same. In all the problems, they will be left alone. The only thing we actually have to do is add or subtract the numerators, the top numbers. So the first problem I have there is negative 11/13 plus 8/13. So the denominator is 13, and it's going to stay 13. The only thing I really have to do is negative 11 plus 8. Well, negative 11 plus 8 is negative 3. That's going to give me negative 3/13. No big deal. All right, the next problem is negative 4/7 minus 2/7. Negative 4/7 minus 2/7. So again, the denominator stays the same. I don't have to worry about the denominator. It stays 7. The only thing I have to do is the negative 4 minus 2. Negative 4 minus 2 is negative 6, and you've got negative 6/7. Now, the next problem looks a little bit different, but it's still the exact same thing. All right, I've got negative a over 9 plus 7a over 9. Now, again, denominator stays the same. So the denominator is still 9. The only thing that changes is this top part. Now, as far as negative a goes, remember, if it doesn't have a number in front of it, you can always put a 1 there. So that's exactly what I'm going to do. I'm going to put a 1 in there. So I've got negative 1a, and then I've got to add 7a's to that. You might want to think of it backwards. 7a's, and then I take away 1a. Well, then I've got 6a's left. So that's 6a over 9. Now, if the a wasn't there, you'd have 6/9. You know that the fraction 6/9 reduces. Okay, I can reduce 6/9 by dividing by 3 and changing that into 2/3. And then in this problem, you just put the a back. Do you absolutely positively have to reduce tonight? No. Okay, not a requirement that you reduce. It's only a requirement that the answers be in a proper format. So you can't have something like 18/13 or something weird like that. Other than that, you're okay. Okay, let's look at the next one. Negative 5 6/7 plus 3 2/7. Negative 5 6/7 plus 3 2/7. All right, this would be an ideal problem to take a mixed number and turn it into an improper fraction and then reverse the process at the end. So that's exactly what I'm going to do. Remember, change these into improper fractions. We would multiply the denominator by the whole number. 7 times 5 is 35. And then we add the 6 that's up there. 35 and 6 gives me 41. Now you'll say, well, wait a minute, what'd you do with the negative? Okay. Once I have 41/7, then I just put the negative back on. You don't have to deal with the negative in the calculation. You just stick it back on at the end. As far as 3 2/7 goes, I'm going to do 7 times 3, which is 21. And then I add that 2 in, which is 23. And I've got 23/7. Negative 41/7 now plus 23/7. That's something we can deal with. Negative 41 plus 23. That's going to give me negative 18 over 7. And then you just want to back it up and change it back into a mixed number. 7 goes into 18 2 times. Leaves a remainder of 4, and the denominator stays 7. And again, there was a negative there before. I can't just make it disappear. So you've got negative 2 and 4/7. Not all of the problems are going to be as easy as the first one. Some of them you're actually going to have to do a little bit of work. Okay, now, the next problem is no big deal, all right? It's just 3 fractions, but it's still a common denominator problem, so I'm not going to have to work that hard. The bottom number is 11. It's going to stay 11.